Okay, so we are back again. We are looking at our paper that is looking at statistical arbitrage. And now we managed in 24 minutes, we managed to talk about co-integration strategy. All right. So this is this side of the paper. So we have got this side of the paper that we've got here. And that's where the co-integration strategy. If you look at all this, you can see that we actually did asset selection, but we can improve this, especially in our demo, the real demo where we are going to download data. We have to improve this. Actually, we have to find a better way of asset selection. And then we have got ADF and the core integration test. We did the augmented Dickey-Fuller test for the assets, the time series for of the two assets X and Y. And then we did our regression. Then after doing our regression, we did again another ADF for as part of the core integration test. So what is next now is the Gotch model, which leads to the trading strategy design. And we have to talk about this in as few minutes as is possible. The point that I'm trying to highlight is that this is what has been the norm. The authors are saying, look, this is what has been happening. And we want to improve this by including the machine learning strategy. So there is this side of life, but we want to move away from this side of life and then implement a machine learning strategy. I think now you get the picture. What the others are working on. They are saying, look, there were ways that were being used to predict the arbitrage opportunities, but now we want to move away from those methods. So we did this. We did test for stationarity in the residuals and all the other stuff. What we want to do now is, and then we got to this point. So what we want to do now, after the co-integration test, we actually found that co-integration exists, and we want to move away from this. We want to say, okay, now that co-integration exists, what is next according to our chart? We must do a Gotch model. And I'm going to assume that you know everything about Gotch, at least the basic knowledge. And we are going to fit a Gotch model to our residuals and see how far that goes, because that is what will give us the arbitrage, where we can say arbitrage opportunities lie. So we are going to get them from the Gotch model. So how do we do this? How do we work on this? That's what we are going to do now. And we are going to start by, if we don't have a package called Arch model, because we need to have this package called the Arch model. And I'm not so sure if I've got it, but let me see. Let me try to import it. And if I import it like that, I might get an error to say, look, you don't have this guy. Yes. So there is no module. There is no module. You can see here it's written, there is no module named Arch. So if that happens, we need to install it. I don't remove these sections of so to install in Python, so you can remove this like that. Then you come here and say, look, co-integration exists. Thank you. Let me write some code, and the code is for installing. Install pip, and then you install Arch, right? So we want to install Arch like that. Okay, then we run it. Let's see. Is it installing? Yes, it's installing, as you can see, because we don't have a module called Arch, so we can't import Arch model. But now we've successfully installed Arch, we can delete all this so that we keep our code clean. And then now I can import, let's see. And if I import like that, then everything is fine. After doing that, what else do I want to do? After doing that, then I need to introduce my model to fit the Gotch model, all right? We are going to use the general Gotch model, the 1-1, right? Gotch 1-1, that's all we are going to do. We are not going to do something complicated. And this is for demonstration purposes only, right? So we are going to fit a Gach 1 You can look at your data and choose to use the other Gach that you want, GJR Gach or some other Gach that you want to use. And let's see now if I fit my Gach model, and I can see that I've got all these things that it's giving me, showing me the number of iterations, the graded evaluations, but this is not important. At least this is not what we need. We want now, so it did this, and this we because we fitted this to the residuals, all right, obtained from the co-integration. So you can see that we fitted it to the residuals that we found from the co-integration test, and you can adjust the order accordingly. And you can also print the results, and see uh, let me just say print here so that I can see what's going on. The kind of, but this is what we have seen already. So we have got these results that we have. Now, it's these results that you want to talk about, all right? But whilst you can talk about these results, we're going to talk about them, but also the plot is the one that gives us a clear idea or the answer to what we are looking for. So let me just start by plotting, then we'll come back to these results and talk about them as well. All right, so I'm going to plot, and as I plot, where do arbitrage opportunities occur? That's what we are interested in. We are interested in checking for significant volatility clusters. So we need to examine this plot to check for significant volatility clusters or spikes. You see where we are having spikes somewhere here and there, and maybe somewhere there, and somewhere there, and somewhere there, because it's at those places where, if we have elevated volatility, it may indicate periods of market stress or potential arbitrage opportunities. So we are interested in that, but we need to take note that arbitrage actually involves exploiting price differentials between the assets that you are talking about. So the Gach model, as it is given now, it's just going to help us to understand the volatility dynamics of the residuals, which may be relevant in assessing the risk associated with potential arbitrage opportunities. So this Gach model that we found, it is essential to consider for that particular reason. And as an investor, it becomes important for you to consider the economic context and conduct maybe some further analysis. That's why the authors are moving away from this technique, because this is just sort of like an indicator, of which indicators is what we all use, what we need. But at the same time, um, we don't get much from these results. Okay, so um, now that we have got the results that we were talking about, let me just go up here a little bit and then say results. Oh, it's a plot. I want to print. Okay, these are the general results that we get from a Gach model. You can tell that this is not significant. Here it's not significant, but beta is significant, and alpha is equals to 1. It's not also significant. And so you look at those, and the constant term in the volatility, which is approximately equal to 0.5912, all right, this guy that we have got here, and the coefficient of the lagged square return, which is this guy, alpha, and then beta, which is the coefficient for the lagged conditional variance in volatility equation. All right, and so the p-values for the mean term, which is alpha 1, is the one that is statistically significant. And let me see, for alpha 1 is 1. No, 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 no. If it is 1, then it is not statistically significant. And but beta 1, the coefficient beta 1 is statistically significant. And what it means is that it indicates strong persistence of volatility, some autoregressive behavior in the time series of residuals. So again, I repeat, Gauge models, they help model the conditional volatility, and the estimation results need to be interpreted cautiously, especially as far as investments are concerned, because there is money involved. So further analysis is required. So because further analysis is required, these guys, they said, look, we now need, after the Gauge model, we now need to come up with a trading strategy design. We move on to machine learning. That's what this business is all about.